Welcome to the exercises for Chapter 12. This chapter is focused on applications in real data, real published data that we can download from websites online, applications of least squares and general linear model fitting, regression, and these kinds of statistical issues. So let's start with exercise 1 from Chapter 12. Now, we saw in figure 12.4 that there was, well, maybe I'll go back and look at this. So here was the observed data, and these are the predicted data. And yeah, it doesn't look very good, right? The model fit is quantitatively low, but it's also qualitatively very poor. And so, yeah, what you would ideally like to see is like a diagonal line here, right? So that the observed data and the predicted data really match very closely. And that is definitely not what we see here. Now, part of the problem is that we are using a very, very simple model to try to predict the bike rental counts. And that's fine because, this is a book on learning the math underlying statistics and not a book about the motivations and dynamics of bike rental in Korea. Nonetheless, the goal of this exercise and the next couple of exercises is to see if we can improve this model fit a little bit. And so, with that in mind, the idea of exercise 1 is to repeat the analysis. So, run the regression analysis again, repeat the graph, produce that graph again. But now we just want to show the data that have non-zero rainfall. So basically, we need to pick the rows. We need to select rows from the data set where the rainfall variable, the rainfall column, is greater than 0. Okay, so now I will switch to Python and show you my solution to this exercise. Needless to say, to run this exercise, you need to run all the code related to this data set. So we need to run this code to import the bike rental. Let's see, well, we don't need this code to generate the scatter plots, but I'll just run it all anyway. But we do need to create this design matrix here and so on. And the regression model, I think I forget exactly which variables we need. So I'm just going to run all of them. And just to see, okay, so I will run the code up to there. We're going to get to the polynomial regression exercises later on. So now here we are. Okay, so I'm redefining the design matrix here. And note that we need to explicitly include a vector of ones, a column of ones, and that's to create the intercept. Now, the intercept can be the first column, it can be the last column, it can be somewhere in the middle. It doesn't really matter where that column of ones goes, but it does need to be in there somewhere. That said, I mean, you do need to keep track of where the intercept column is because that gets mapped onto the beta values, of course. Okay, so run this line of code to recreate the design matrix. And then basically a lot of the important stuff happens here in these two lines. So what I'm doing is selecting the data. So I'm creating a new data set that comes from the design matrix, but it's the design matrix where the first column has values greater than 0. And that first column corresponds to this variable here, which is rainfall. Okay, now notice here also I'm assigning this to be a new variable. So I'm not overwriting the same variable. That's generally good practice. If you are filtering data, you're selecting data, then it's generally good not to overwrite previous variables that can lead to confusion and possibly errors. Of course, sometimes it's fine to overwrite variables, but here I don't do that. Okay, so then another reason why we don't need to do that, or why it's not a good idea to overwrite this variable, is because I'm also using it here. So imagine if I said, well, we're recreating the design matrix here, so do we really need a new variable? Maybe, let's just leave it like this. Now, this line on its own is okay, but now we're using that exact same variable, which already excludes 0 rainfall days, and I'm using that to select rows from y, from the dependent variable. So that means if I would write the code like this, there's going to be a mismatch between these two variables. All right, that's just a little bit of coding. Okay, let's see. And then we run the plot again. I think this plot isn't so interesting, but good to see. It's always good to visualize the data. And here is where I rerun the regression. And now you can see that, in fact, the model does worse. So let me scroll here, go back to the book for a second. So keep this in mind, this number, 0.028. And here we have a value of 0.097. So although this is not a good fit to the data, this is also not a good fit to the data. It's an even worse fit to the data. And yeah, I mean, it certainly doesn't look like a line here in this space of observed data by predicted data. Now, on the one hand, maybe that's a little bit disappointing. If we are working with these data for real, then, definitely we would need to try to rethink our modeling approach and figure this out. But on the other hand, exactly this line of thought that I developed for this exercise is the way that you start doing data science and regression modeling in practice. You start looking at the qualitative and quantitative fits of the model. And if it's not very good, if the model doesn't fit very well, you need to start thinking about what can be changed, what might go wrong, what can we update about the model or about the data. And in this case, we had an hypothesis, we tested our hypothesis, and it turns out that we were wrong. So this modeling approach is not better, but it's good to be wrong because every time you're wrong, you're learning something. So it's not always about just getting things better and better. It's about learning more and more, and that's going to make things better in the long run. Anyway, I hope you enjoyed working through this exercise.